In this lesson, we're going to take a look at absolute value equations and absolute value inequalities. As you can see here, we have an absolute value equation of 2 times the absolute value of x minus 5 minus 3 equals 5. So the first step in our process is that we have to isolate that absolute value. We're going to treat the absolute value like we would a quantity in another equation. So it has to be isolated first before we can do anything else. So the first step is to do the opposite of the order of operations, just like you've done before to solve for x. So we're going to add 3 to both sides. Once we add 3 to both sides, we're going to end up with 2 times the absolute value of x minus 5 equals 8. Now you've got a 2 that's being multiplied against the absolute value of x minus 5. Because division is the opposite of multiplication, we're going to divide out a 2. That then is going to leave us with the absolute value of x minus 5 equals 4. Once we've isolated the absolute value, we need to create 2 new equations, and we're going to drop the absolute value signs from those new equations. The second equation, what we're going to do is we're going to make what it's equal to, what's on the right side of the equal sign, a negative number. Okay, so you'll see on here that we've got x minus 5 equals 4 and x minus 5 equals negative 4. Now we're going to solve these separately. So let's take a look at the first one. You have x minus 5 equals 4. So again, we've got to isolate x. Add 5 to both sides, you end up with x equals 9. On the second equation, you have x minus 5 equals negative 4. Again, isolate x, so add 5. You end up with x equals 1. Okay, so these two should be our answers. But we do want to go back and check just to make sure that we've got the correct solutions. So in order to do this, all we're going to do is take what x is equal to and substitute it into the original equation. So if we take x equals 9, we're going to do 2 times the absolute value of 9 minus 5 minus 3 equals 5. Work inside the absolute value first. So this time we're going back to regular old order of operations. 9 minus 5 is 4. The absolute value of 4 is 4. So 4 times 2 is 8, minus 3 equals 5. And we see that 5 equals 5. So we do know that that solution is correct. Over on the other one, x minus 5 equals negative 4. We had a solution of x equals 1. So we're going to take that 1, plug it in for x. So we end up with 2 times the absolute value of 1 minus 5 minus 3 equals 5. 1 minus 5 is negative 4. The absolute value of negative 4 is 4. 4 times 2 is 8. 8 minus 3 is 5. So we find that 5 equals 5. So both of our solutions are correct. So now we're going to take a look at solving absolute value inequalities. Solving for absolute value inequalities is pretty much the same process as solving absolute value equations. There is a slight difference, and that's an important difference. We're going to start off with basically the same inequality as what we had with the equation. All the numbers are going to be the same. We're just changing the equal sign to a less than or equal to sign. So again, the first step in the process is to go ahead and isolate the absolute value. You can see that we have 2 times the absolute value of x minus 5 minus 3 is less than or equal to 5. So we need to first get rid of that negative 3 by adding 3 to both sides. Once we've done that, we end up with 2 times the absolute value of x minus 5 is less than or equal to 8. Since 2 is being multiplied against the absolute value, we're going to divide both sides by 2, leaving us with the absolute value of x minus 5 is less than or equal to 4. Once we've isolated the absolute value, we're then going to repeat the same process that we did with equations. We're going to split the inequality into 2 inequalities. This time, x minus 5 is less than or equal to 4, and x minus 5 is greater than or equal to negative 4. Now notice, on the second inequality, you're going to have to flip the sign from less than or equal to greater than or equal to. If you don't do this, you're not going to get the correct solution. So let's take a look at the first inequality that we've got. X minus 5 is less than or equal to 4. The first step in the process is to go ahead and isolate the x. So we're going to add 5 to both sides. That's going to give us x is less than or equal to 9. The second step in the process is to take a look at the second inequality, which is x minus 5 is greater than or equal to negative 4. Again, we're going to isolate the x, so we're going to add 5 to both sides. This time we're going to end up with x is greater than or equal to 1. Once we've got our two solutions, the next step is to go back and check them. So we're going to take the 9 and we're going to plug it back into the original inequality. So it's going to be 2 times the absolute value of 9 minus 5 minus 3 is less than or equal to 5. So again, start inside of the absolute value. 9 minus 5 is 4. The absolute value of 4 is 4. 4 times 2 is 8. And 8 minus 3 is 5. So 5 is less than or equal to 5. Over on the second inequality, we're going to plug the 1 in for x. So we're going to have 2 times the absolute value of 1 minus 5 minus 3 is less than or equal to 5. Again, remember that we're using the original inequality, so that sign is getting flipped back over to less than or equal to. So again, we're going to take a look at this. 1 minus 5 is negative 4. The absolute value of negative 4 is 4. 4 times 2 is 8. 8 minus 3 is less than or equal to 5. 5 is less than or equal to 5, so then we know that we've got the correct solution. Once we've done this, we're going to go ahead and put our solutions on a number line. And again, because we're using less than or equal to signs from the original equation or from the original inequality, we're going to have closed circles on our number line. So we're going to go ahead and put the first closed circle on 1 and the second closed circle on 9. Since x is less than or equal to 9, our arrow is going to go to the left. Since x is greater than or equal to 1, our arrow is going to go to the right. And you can see that our solution is going to be every number between 1 and 9 inclusive of 1 and 9.